Okay, hello, hi. In this video I'm going to explain to you how to install the telescope model Celestron, the company. Model number is AstroMaster 130 EQ. Okay, now EQ means it's an equatorial one which can rotate in all directions on the tripod. So this is the tripod. Now in this video also I'm going to explain to you how the telescope works, so you can see like for real, not just things that you have or you have learned or you learned in the past from your high school. Okay, so first of all, this is the tripod. This is where the telescope goes down on this top. Okay, and we will open the screws here. Okay, so we can put the legs as much as we want, and then we screw on that. So we do it again for the other two on here. Now we push this to the max. Okay. So. And then we make sure that this is pushed to the max. Okay, and then we get this plate. Okay, there's a hole on the side here. We'll just put the hole. There's some place here in the middle. Okay, here we have to put the hole. Okay, like this, and here will be like clamps or clippers or whatever. Okay, so they hold the plate stiffly, okay, and firmly, and this is just to prevent the tripod from collapsing. Okay, that's good for you later when you put your eyepieces. You can put them here. Okay, good for your T2. Okay. Now, we get the equatorial part, this one. Okay, this is the piece, okay, where you put the telescope right here. Okay, those screws over here. Okay, well, this is the telescope, the tube. Okay, this is where you're looking at, and those screws will be like holding the tube of the telescope on its rail. Here there's a rail here, okay, and those knobs, okay, there's two of them, so you can just move this. Here there's a screw, okay, put this screw. There's a place in it like some kind of groove, a little groove, okay. You put the screw on it, okay. You know it when you put the knob, okay. So this knob, okay, can like make your viewing in the telescope fine-tuned. So you can make it a little bit up, a little bit down, a little bit to the left, a little bit to the right, okay. So you can always center the view always inside the telescope, okay, inside your view, okay, and your reflex. Now here you see there's like a protractor, okay. Those protractors are used for you when you wanna use a coordinate system just to find the object that you wanna shoot in the skies. Okay, so if you use some kind of coordinate system using the astronomy, you can use those to find the correct location of the star. Okay, based on the right. Now here I put this piece of metal aside this one, okay, like here, and this is just to make a counterweight. Okay, so it also has a screw here, So if you look with me now, see it from the okay. So from this point here, you have it like 120 degrees inclination. You can make it, for example, a 60 by clicking by moving this screw, and by screwing or unscrewing depending on your needs. Okay. So see, it was like 120, now it's on 40. Now I put like here. So there's this screw on the bottom of the top of the cardboard. And now it's on the screen. Okay. Okay, so you make it a little bit loose so you can rotate it left or right, okay? Now, so you can rotate this like this, and you can rotate this like this, okay? And this way you can do. So you have a 360, a whole ball, okay, whole sphere, you can rotate all around, anywhere you want, okay? Now, and if you want to make it hold it like in a way, so if you want to make it held on you in a way that it won't rotate, those screws here, okay, and over here, okay, just to keep it in its place, okay. So if I like move this, see, I can barely move, okay. Now, okay, here, start with this is the telescope here, this is the telescope, okay? All of this is just to make the telescope be pointed at some place, at somewhere you want to see, okay, through the telescope. So this is the apparatus, okay? Okay, now, I open it here, okay? This lid, okay? Let me just put the telescope on the ground, on the floor. So, it has this lid, small lid, so you can just see this part. You don't have to see the whole view. Okay? Now, before I put the telescope, of course, I forgot to say that I have to put this, the counterweight. So this screw, okay, has like this hole. This hole has inside it something like a bullet, okay, a little nail, something like this. Okay, so you see it's a little bit round on the top, pointed, and it's a clean cut on the top, on the other side. I mean, so I put this from the pointed top to the inside. Okay, like an egg. And then I get the screw. I will it like this. Okay. You can this way put the counterweight up or down the way you like it. Okay. So make a space between the counterweights. Each one is like 5 kilos. Okay. So like I said, first make it unscrewed. Okay. And just put this side. Okay. That's about to make a few four. Okay. You will. So because the audio that you buy is the glasses. Okay. That's why they are expensive. Yeah, because of the technique and the design that they are made for. Okay. So by the design. Okay. And by the way, this here, this orange side, or the orange side, you can unscrew it too, okay, if you want. here in the telescope, I have here also the eyepiece. So there are some screws here which can hold the eyepiece. This is where I look through, so I can see what's projected inside the tube or the telescope. Okay, I will move later the camera so you can see better. And this is just for focus and zooming the view. Here you will have always 2 points in the telescope where you can see clear images. Okay, only 2 points. Okay, so there's a physical reason for that. Okay, just because how the focuses of the lenses and the concave mirror is is created, is made. Okay, now here I have, this is the rail, put it over here, okay, and then here, here, yes, okay, here, this is like the screws for a clamp. So you have the tube being clamped, okay, like what I'm doing in my hands, my fingers, just as a clamp, just to hold the tube on the rail here, okay. This label is good for you to leave always, just to make sure, just to warn you that you just, that you have not to put, or you must not put the telescope facing the sun. Okay, see, it says like this is the sun and it's banned. It means like a scale back, okay? Smoking back, yeah. So like this. So I screw this screw and this one, okay? Let me see what's happening in the camera. Okay, great. So now this one is used just to like the rifle pointing, like when you point using the rifle, same thing here. Okay. So you point at the very far thing just to make sure that you get it inside this tube. Okay. Now here I have also another eyepiece similar to this one, but I'm going to show you something. Okay. So okay, I hope you can see it. Anyways, I'm trying. I'm not seeing inside the camera preview. So you see it here written on it like a 20 millimeter electron eyepiece. Okay, so this one has a focus on 20 millimeters. So you can see the far image, okay, in front of your eyes on 2 centimeters. Okay, and this one has 10 millimeter focus. So you can see your far image on 10 millimeters or 1 centimeter. Okay, and there are other levels. There's 1.6 millimeters, there's 1.4, and there's another 1.2 millimeters. Okay, the smaller focal length means that you are zooming more. Okay, you're asking to see further or farther. Okay, the farther places. Okay, so when you use it, you have to start with the 20 millimeters. Okay, then you go for the 10, and then you go to the 6 and the 4 and the 2 and so on. Okay, this way. Okay, and the shorter the focal length, the eyepiece here, the opening of the eyepiece will be smaller. Okay. Now, let me first move the camera a little bit into the telescope. Okay, now I'm going to lower the telescope because I want to show you something inside the telescope. And by the way, always hold the neck before unscrewing the screw that's on the back of the equatorial. Okay? Okay, great. Now it's facing. So you see here, this is my hand, okay, and you see here that there's a mirror inside. So what happens is that the far things, okay, which has a light, okay, will project the light and go through this tube down to the this zooming concave length, okay, a concave mirror, okay. So concave or convex, I don't recall, but this mirror will enlarge, will zoom the lights, okay, and condense them at some point, which is facing this. It's a concave length mirror. I mean, yeah, it should be. So into this place here, okay. Here in the inside, I need some light to show you it, okay. But just understand, at the extension of this, here there's in the inside here, okay. Okay. I'm trying to hold it, okay, like I told you before. So you see another mirror. So what's coming from the fireplaces, okay, and their light reflection will go into the tube, down to the mirror, and from the mirror go to another normal mirror, like your bathroom mirror or normal reflecting mirror. It doesn't focus the light, okay. So it goes over here just to reflect the image as is, okay. So it's a matter of decoration. This is not a matter of the telescope physical thing or its real task. This is just for me, just to watch like from this side, rather than from watching from this side directly, okay. So instead of looking from here, okay, I'm looking just like this, okay. So I put the eyepiece over here, and the image that's reflected, it goes to the focus of this eyepiece, and therefore you can use those wheels just to zoom in and zoom out, okay. So if we look together, you see here the reflection of the mirror from outside, okay. So this is the telescope and how it works and how to install it. And yes, this is AstroMaster. Celestron EQ 130. Okay. that's all, folks. Okay, so that's all, and goodbye. Please don't forget to click the ads and the comments and type something and tell me if you like it using the likes. Bye.